This is a podcast for Rules of Exponents Day 3. So today we're going to review the rules that we learned Day 1 and Day 2 and do several practice problems. So the first rule that we learned was called the product rule. Product means multiply. So if you have two exponents with the same base, 9 is the base, the big number, 9 to the 12th power, where 12 is the exponent, times 9 to the 3rd power. We worked at expanding this and then coming up with a shortcut. So the shortcut is if they have the same base and you're multiplying, you add the exponent. So 9 to the 15th power. So again, the product rule would be a to the m plus n power. If you have two exponents with the same base that are being divided, this is the quotient rule. Quotient means divide. So this would be x to the 3rd power. A way to think about it is 5x is on top, 2 on bottom. When you cancel, how many are left and where? There's 3 left on the top. The rule that we looked at was a to the m minus n power. The negative exponent rule, if it's negative on the bottom of the fraction, the denominator, you can flip it to the top and make it positive. So this would be a to the n power. If it's negative on the top, you could flip it to the bottom and make it positive. So that's down here. If you have a to the negative n power, you can make it positive by writing it as a 1 over a to the n power. The zero exponent rule, anything to the 0 power is 1. And so I should have made this a 0 right here. And then a power to a power rule, you multiply the exponents. 4 times 3 is 12. So this is x to the 12th. This is a to the m times n power right here. So like I said, we're going to do several examples today. I believe there's 10, so let's work through them, and then we're going to have another assignment where you're going to try to find the error of people using these rules of exponents. So the first one, start with our number basis. 2 times 4 is 8. Then look at our x's. We have x to the 3rd times x to the 5th. So if we add the exponents, we have x to the 8th power. Then we have y to the 6th and y to the 7th. So if we add the exponents, we have y to the 13th power. Division, let's start with our numbers. 16 divided by 2 is 8. You have 5 x's on top, 2 on bottom. So when you cancel, there's 3 left on the top. And for the y's, you have 7 on top and 8 on the bottom. So when you cancel, there's 1 left on the bottom. Okay, let's take a look at a few more. So 3 and 4 are very similar to 1 and 2. So over there, 12 times 3 is 36. You have 1a here and you have 2 here, so this is a to the 3rd power. 9 b's and 5 b's, we have b to the 14th. Number 4, 2 divided by 12 is 1/6. You can write the 1, you don't have to. Well, maybe not put the 1 here, but it's 1 over 6. We have 9 a's on top and 1 a on the bottom, so when you cancel, there's 8 left on the top. We have 3 b's on top and 10 on bottom, so when you cancel, there's 7 b's left on the bottom. So this is a to the 8th power over 6b to the 7th. Number 5, we have everything to the 0 power. We're going to distribute that 0 here. So we have 4 to the 0, d times 3 to the 0, and then m to the power of 100 times 0. Here's what it looks like if we show our work. And we know that everything to the 0 power is 1. The next one, b to the 8th over b to the 11th. So we have 8 b's on top, 11 on bottom. When you cancel, there's 3 left on the bottom. And on the top, there's really a 1 there. Because if we cancel everything, anything divided by itself is 1. So there's a 1 there. The next one, we have g to the 3rd power raised to the 5th power. So we multiply the exponents, g to the 15th. For the negative exponents, you can flip them to the opposite spot and make them positive. So this is s to the 4th over r to the 5th. Well, now my workspace quit on me. So I'm going to quit this. I can go to my document, I'll do that. And let's go to the very last one. Let's see if I can get this workspace restarted here. All right, the last one, a power to a power. This is 3 to the first power, so we will distribute the 4 to the 3, 3 to the fourth power, p to the, and you multiply the exponents. 2 times 4 is 8. 3 to the fourth power, excuse me, is 3 times 3, which is 9. 9 times 3 is 27. 27 times 3, let's do that. 21. 2 times 3 is 6, 7, 8, 81. So this is 81 p to the 8th power. And the last one, similar to like the first problem that we did, we have 25 times 2 is 50. A to the 3rd times a to the 8th would be a to the 11th power. All right, so we spent 3 days looking at these rules. Your assignment is to go through, and I believe it's find 4. Let's see if I can find it right here. Find 4 that have errors, like 4 have errors and 4 don't, but let me double check. On day 3, so the directions say, the following statements are all incorrect. Okay, identify the mistakes, rectify, justify your reasoning. Okay, so they're all incorrect. Can you make corrections using your rules? All right, that's it.